Okay, the second part of our videos on square roots and radicals is going to be dealing with multiplying radicals. And hopefully you recognized from the last section in which we were simplifying radicals the process that we're going to use for actually multiplying radicals together. When I have two radicals, let's say I have 3, the square root of 3 times the square root of 5, what I do is I multiply the radicands together. So I take 3 times 5, that's still under a radical, it becomes the square root of 15. Again, if I have something like the square root of 2 and I'm multiplying that by the square root of 6, I multiply the radicands together, giving me the square root of 12. Now once I have the square root of 12, if I can simplify that, I should. I know the square root of 12 is 4 times 3, square root of 4 times square root of 3. So that will give me 2 root 3. So in its general form, what multiplying two radicals is, if I have the square root of a times the square root of b, that gives me the square root of the product of a and b. So now we're going to take a look at some of the example problems that are on the review packet I gave you. We're going to do half of them, the other half will be for you to finish and turn in. Okay, so multiplying square roots. Again, when I'm multiplying the square roots, I multiply the radicands together, so 5 times 5 is 25. That's still under the radical. I know that's a perfect square, and I can simplify that. The square root of 25 is 5. Number 2, multiply the radicands together, so 10 times 2 gives me the square root of 20. Again, if you can simplify that, you should. 20 can be factored to 4 times 5, 4 being a perfect square, so the square root of 4 times the square root of 5 gives me 2 root 5. Number 3, multiply the radicands together. I have then the square root of 8 times 8, which is the square root of 64. Square root of 64 is just 8. Remember, when you take the square root of a perfect square, the radical symbol is gone. You just have the square root of that radicand and no radical symbol. Number 4, I have 20 times 10, which is going to give me the square root of 200. Recognizing that that's 100 times 2, and that 100 is a perfect square, I get the square root of 100 times the square root of 2. Square root of 100 is 10 times root 2. So again, I'm just multiplying the radicands together and then simplifying these square roots. 3 times 3 is 9, so I get the square root of 9. That's a perfect square. That gives me 3. Number 6, when I multiply the radicands together, 5 times 12 is 60. I get the square root of 60. 60 can be factored to 4 times 15. So that gives me the square root of 4 times the square root of 15. Square root of 4 is 2 times the square root of 15. Now the next question actually adds one more level, and that is that I have a 2 in front. And I haven't had that yet, so what am I going to do with that? Well, I'll multiply the coefficients on the front together. In this case, I only have a 1, so 2 times 1 is 2. Then I'll multiply the radicands together, square root of 24. Now 24 can be factored into 4 times 6. So that means I have 2 times the square root of 4 times the square root of 6, 2 times 2 times the square root of 6, so my answer is 4 square root of 6. Now as you become more proficient, you don't need to write all of the steps. Write as many steps as you need to make sure that you won't make a mistake. But for this practice, I'm going to write all of the steps for you to see. Number 8, again, there's no coefficient in front of that square root of 5, so it's just a 1. I'll multiply the 1 and the 2 together, and I get 2, and multiply the radicands together, square root of 10. There's nothing, I can factor 10, but I need a square root. And since the only two square roots smaller than 10 are 4 and 9, and neither of those are a factor of 10, there's nothing else I can do to simplify that. Now let's skip further down the worksheet to look at the distributive property and multiplying radicals. Again, just like if I had 2 times x plus 3, I would multiply 2 times x to give me 2x and 2 times 3 to give me 6. I'm going to do that exact same process. It's just now I have radicals. So I'll take the square root of 15 times the square root of 3. That will give me the square root of 45. Almost wrote a 9 there. Square root of 45. Then I'll take 15 times 2. Note that that 2 is not under the radical, so I'm going to make that plus 2 times the square root of 15. I'll multiply the coefficient in front of that 15 by 2, but I don't have a radical or a square root symbol to multiply those radicands. Now I need to simplify 45 factors to 9 times 5 plus 2 times the square root of 15. So I have the square root of 9. 9 is a perfect square. Square root of 5 plus 2 square root of 15. This gives me 3 square root of 5 plus 2 square root of 15. And you should stop right here. You cannot combine, you cannot add those radicals together because the radicands are not the same. In order to add two radicals together, the radicands must be the same. These cannot be the same, cannot be made to be the same, so stop right here. Okay, number 14, again, just like the distributive property, 6 times 2 gives me the square root of 12, and then 6 times 3 gives me the square root of 18. The square root of 12 can be factored to 4 times 3. The square root of 18 can be factored to 9 times 2. I have the square root of 4 times the square root of 3 plus the square root of 9 times the square root of 2. Taking the square root of my perfect squares gives me 2 root 3 plus 3 root 2. And again, stop right here. You cannot combine because those radicands are not identical. And that's the only way you could combine them, is if they are identical. Number 15, square root of 10 times the square root of 10 gives me the square root of 100. Then the square root of 10 times 2 gives me 2 square root of 10. Square root of 100 is 10 plus 2 square root of 10. Again, stop. Don't make that 12 root 10. That's an entirely different number. In fact, if you take 10 plus, let's do that in our calculator, 10 plus 2 square root of 10, I would get that that's approximately equal to 16.32. Now, if you tried to combine that and you tried to say, well, that's 12 square root of 10, 12 square root of 10 is approximately equal to 37.94. So those numbers are very, very, very different. Again, they are not equal, so don't add that real number and then that coefficient and the radical together. They are separate. Number 16, square root of 5 times the square root of 5 gives me the square root of 25. Square root of 5 times 3 then gives me 3 times the square root of 5. Again, 25 is a perfect square, so that's 5 plus 3 root 5. And again, you can't combine those. You need to stop right here. You cannot combine those because they do not share a common radicand. This little video was on simply multiplying radicals and using the distributive property. Remember, when you multiply radical or square root expressions together, you multiply the coefficients in front together, you multiply the radicands together, then you see if you can simplify them. I hope you learned something from the video. Have a nice weekend. Where did it go? It's still going. Where is it? It's where? Where is it?